DiscoverSTEM, and this is DiscoverSTEM 2025. And you can see here, like, we have a lot of people around. So this is a reverse science fair. You might have seen science fair or heard science fair in the high school. This is reverse science fair because here adults are presenting and kids are attending, the middle schoolers and high schoolers. And we have a lot of companies, actually 49 companies, one less than 50. And they all are local companies, but there are some Boston based companies also, like Boston Dynamics. Some companies have come from Burlington. It's the Nth Cycle, and we have a lot of Acton based companies, Boxborough based companies also. And we cover a diverse field. So it's biotech, we have robotics, we have sustainable energy, we have a lot of things. And you see, a lot of, all the exhibits seems like they're busy, so a lot of students are here. Yeah, that's us. And this is after 2019, so we are bringing it back after 6 years. So post-COVID, so looks like a big hit, so great.
And I'll just say, so I'm a science teacher here at the high school, Brian Dempsey, and I live in Boxborough, and so I've been telling my students about this great event, a way for them to explore different careers in all kinds of areas in science technology. So we're very grateful to ABSTEAM for putting all this together.
How you doing? I'm Anthony with UMass Lowell's Francis College of Engineering, and here today we have a little bit of the sports engineering side of the school. We are the only school in the country that offers sports engineering as a minor, and it kind of works in cohesion with what we do at the Baseball Research Center, which is on campus at UMass Lowell. We have a bunch of big companies like the MLB, the NCAA, and other sports-oriented companies that give us their products so we can test them out and make sure they're top-notch and ready to go for game day.
All right, so this is our experiment to test the nodal frequencies of the bat. So along it, if you tap it, it will make a sound. And when you know you hit the sweet spot, when you begin to hear the paper vibrate like that. And there will be one all along the bat up here too. And when you hit the sweet spot, the ball will just go further than when you don't. So we test where the location of it is.
Hi, I'm Matt. I'm with Product Insight. So we're a design and engineering consulting firm. We do a lot of warehouse automation, biotech, and a lot of workforce support with automated hardware. So we'll go in and figure out the challenges that our clients have and figure out the best way to support them with robotics. And then we'll bring all of that information and design research, synthesize that through industrial design and engineering design, and come out with proof of concepts and test them out in the field, get user feedback, and really synthesize that into a full total product. And then we'll design and engineer the final product and give that back to our clients to either implement or make at scale. So over here, we as a company have worked on a lot of interesting manipulators. So I challenged our team to make me a really interesting dexterous manipulation type machine. So in a few weeks, they took an open source design, put it together, coded it, and got it up and running so we can do some nice trade shows. And we can kind of show the synthesis of our engineering team and software team and how they can come together to design new products.
Hi, I'm Felicia and I'm the branch manager at the Acton location of Northern Bank. I'm here today playing Jeopardy with the kids, learning about banking, from anything from savings to debt to credit to budgeting, just to interact and check out their knowledge. We have in budgeting, what is the standard budget rule percentages, meaning needs, wants, and savings? The answer is 50% in needs, 30% in wants, and 20% for your savings.
Okay, so this is a robot built in SolidWorks, X-Design. So we are showcasing a concept called mechatronics, right? You put mechanical and electronics together. So here in the software, you can build a whole thing, and you can use the mouse, move these sliders here, and you can test it out, and then 3D print it here, and then put it together and test it out. So if you have an idea, you can build it in SolidWorks, print it, test it, and sell your idea.
Hi, so I'm Karen Root Watkins with EnergizeActon.org, and we're a community organization hosted by the Acton Sustainability Office and the Acton Climate Coalition. And our whole reason for being is to help people find resources to embrace a clean energy future. So we have the poster here of what a clean energy home would look like, and all the different activities you can do in your home to decrease your carbon footprint and put less CO2 in the atmosphere, from insulation, which Mass Save will help people do and really save you a lot of money, and big ticket items like solar panels, electric vehicles, air source heat pumps or ground source heat pumps, but then also smaller things people can do like an induction cooktop. And we have a website, and people can find all sorts of actions that they can embark upon, including nature-based solutions and things like composting, buying less stuff. And we do all different kinds of educational events, from clean energy home tours to plant-based food picnics, which we're having one this weekend, our plant-based harvest gathering. So we're just trying to be a resource for the community and address our climate warming situation by making a positive difference.
My name is Ben, I'm with AECOM, and this is a little bit of an overview of our environmental remediation practice. So all this here is pretty common equipment we use on a day-to-day basis while we're in the field. So if you don't know, remediation is more or less the cleanup of contaminated media, whether that's manufacturing, commercial, or residential. There's a lot of construction involved, a lot of heavy machinery, but also there could be nothing involved, a lot of long walks in the field per se. But this is all very, very common equipment. We have water levels that just tell us just the depth of water. This is a pump we use just to see, to control how much water we're pulling out. Turbidity meter with different standards just to see how clear the water is. These are calibration samples to help calibrate our YSI probe right here, which really gives us the nuts and bolts on water quality and helps us determine how clean or how dirty the water is. But we do a lot of water sampling, a lot of soil sampling. We drill. A very new phenomenon that we do a lot of is vapor intrusion in subslab depressurization systems. So that's very similar to a radon system that you'd find in a house. I do a lot of this work, so I'm pretty versed in subslab systems. It's really, really a revolving world with a lot of new technology every day. I mean, there's technology in our safety helmets where you can hold your phone up and it tells you medical information. Really just a general overview of a lot of our common tools and techniques within environmental science.
Hi, my name's Travis Miner, and I am here with Open Door Education, where we are sharing some pretty cool science experiments for students to think about both math and chemistry in slightly new ways. We're a tutoring center, and so we're really experienced in helping students understand classroom content, and one of the things that we're hoping to help students with is thinking about math outside the box and also thinking about some real-world applications. That includes the 3D printer that we have and some of the 3D printing, the outcomes that you can also see, not just the 3D printer in motion, as well as a couple of experiments. In fact, here we're looking at how many packing peanuts can be fit into a single film canister. We've got a challenge going. If you're interested in learning more about Open Door Education, you can find us online at www.opendoor.education or come visit us in person. Our offices are located next to the Acton Library, and also we have a new classroom space at Kelly's Corner here in Acton.
All right, so here we have our groundwater model. We take this around to show people how water kind of moves through our aquifers. So Acton, we get our water from about 24 different sand and gravel wells all throughout the town. And so these wells kind of represent those wells that we get water from. And so we just like to demonstrate to people, this water bottle up here, it's representing rainfall, so it's trickling just a little bit and getting into our system here. And it's gonna trickle all the way through our sand and gravel here, and it's going to eventually come out to our stream, right? But the thing is, right, when I start pumping a well, and let me do that for you here real quick, and keep an eye on all the wells, and you'll see something happen. Hopefully you can see it on the camera, but all the other wells around the well I'm pumping, all the water levels coming down. And so we're pumping pretty much all the time at Acton. So we like to show that water's always being pumped out and it's coming, from all over the place. And a great example here that we do show is that this is an underground storage tank. And so I put some food coloring in here a little while ago, and you can see there's a plume of red slowly migrating its way over to the well that I was just pumping. And so that kind of represents that water's migrating, and it's also pulling pollutants with it. So we have a lot of different treatment that we use to make sure that the water's clean, right? We treat for VOCs, we treat for PFAS. That's probably something that you've heard about maybe out in the news out there. And we also treat, because you can see this lake here, we also pull water in from surface waters when we pump our well. So that water will kind of migrate over. And so we use this fancy little filter here. This is called a membrane filter, and this helps us remove all the specifically Giardia, right? That's what we're mostly concerned about, along with other, kind of organics and stuff like that. And that helps kind of clear up the water, keep it clean, nice and clear, tastes better, right? And that's kind of all that's involved in this little display here. So I hope you enjoyed it. Thank you.
We are Nipro Mold. We are in Clinton, Massachusetts. We design and build steel molds used to make plastic parts. You won't have heard of us, but you've heard of a lot of our customers: Abbott, SC Johnson, Procter & Gamble, Gillette, and that we do high production, high accuracy molds for the plastics industry. Some of the steel molds we do, this is highlighting a deodorant body, and we machine traditional up to here. And then the rest of that is 3D printed in steel for the final shape. You won't recognize the steel, but you'd recognize the plastic parts that we have. Shampoo caps, creamer caps, urine cups, and then some inhaler devices.
How you doing? My name is Mark Roberts, here with Neshoba Air and Boiler Works. I'm a home comfort advisor. Today we're here just teaching about heating, air conditioning, plumbing and electrical, showing some of the software we use. We use a new program called Conduit Tech that builds a 3D print of your home, gives you an exact layout of how many heating and cooling BTUs you need to maximize the efficiency in your home, to ensure that we properly size your heating and air conditioning equipment. Also encouraging kids about the trades and learning about different parts of our plumbing department, heating, cooling, and electrical. Here we got a few different flyers, running some water tests here with our master plumber, Brad. So anybody that'd like a water test, we're offering free water test as well today. And just here to educate and answer any type of questions for any type of heating and cooling needs in your home.
Hi, I'm David Kleinschmidt. I work for New England Clean Energy, and I'm here at the ActonSTEM Career Fair talking to folks about renewable energy, how solar plays a part in that, and to connect kids to careers in renewable energy and all the different STEM, science, engineering, and math components of school that are related to renewable energy. Lots and lots of aspects to that, so we need lots of kids to get involved in those types of educational outlets, and then they can come work in our industry or another one like it. This is a modeling tool that we use to project how much electricity a building can create with solar on its rooftop. As you look at those colors on there, that represents the solar gain that's possible on the roof. The brighter colors are more solar capable, the darker colors are less. And we use some fancy software to help us with that. It has a bunch of different data in there. I can show you one aspect of that. This is called LiDAR, which helps us understand the shading elements that are related to a building, and also the shape of the building itself. So lots of little tools that we use to help us accurately project how much solar a building can generate. This is a sample of a photovoltaic cell. This also is a microinverter. So the photovoltaic cell collects the sunlight and it converts it to direct current. The microinverter takes that direct current and converts it to alternating current, which is what's used in your home or your business. We need lots of engineers, scientists to create the next generation of photovoltaics or renewable energy source, as well as design other components that go along with it, whether it's mechanical parts or the chemistry that goes into it or the electronics that's into it. So chemical engineers, electronics engineers, mechanical engineers, we need material scientists to develop the next generation of photovoltaics.
Hi, so we're here to present Qualcomm's work over generations, starting off with the CDMA, which led to the first G, or the 1G and the 2G, which started off with simple ability to make calls and send the first text message, and over a span of 22 years, we've now gone to 5G, where you can download like a 30 GB of worth of data within a span of 4 minutes. So that's like a reduction from 50 days to 4 minutes, and the chip size that enables you to do this has consistently reduced. So this is from the modem aspect of it, but Qualcomm does a lot more stuff where we have a graphics unit which designs GPUs, and now we're into the edge AI, and we have our own AI chipsets, which basically runs your AI models, which are about 7-8 billion parameters or even larger, on a device like a laptop. And our latest is the Snapdragon X Elite, which if you get a chance, you should try it out. Amazing battery life with AI offline, and we also have new chips that's debuting next year in the Humane cloud farm, data farm for AI inferencing. So yeah, glad you could check out. Do visit our webpage when you get a chance.
Hi, we're from Tufts University at this coming School of Veterinary Medicine, and this is our display today. We have many models that we have made at Tufts University that we use to teach our students to do procedures before using a live animal. We've also brought some microscopes with some histology samples, some blood, and a heart that has heartworm in it. You can see that it's been cut, and you can see the heartworm that comes from a mosquito. Dr. Napier is helping a student learn how to suture using models that we make at Tufts to make the skin layers, so they have something to practice on before they use a live animal.
Hi, we are with the Health and Human Services Department for the town of Acton, and we are working on two big projects for the town. One is a community health needs assessment, and the other one is an equity audit. We want to understand what are the needs of our community today. What are our healthcare needs? What are our behavioral health needs? And then what are the other needs that help us live a happy life, whether it be transportation or housing or anything like that. And then with the equity audit, we want to know how to get you involved in our community, get you moving to be in our programs, get you to be voting at town meeting and participating in our boards and commissions. We want to see everybody in Acton participating in what we have to offer. So that's what we're here for today.